All right, page 174 in your textbooks, we're going to begin by taking a look at the extra credit. And Gavin sent in extra credit. I don't know if it's right or not yet because I haven't checked. But we're going to take a look at that. Anyone else take time to do the extra credit last night? Noah, you did? All right, so just Gavin and Noah. Let's see how we did with this. Noah, if you would, read word problem number 6 for us, please.
The tens digit of a two-digit number exceeds twice the units digit by 1. If the digits are reversed, the sum of the new number and the original number is 143. Find the original number.
All right, so Noah, the first sentence is our first equation, but it's worded kind of weird, isn't it? The tens digit of a two-digit number exceeds twice the units digit by 1. Could we translate that into more like normal English? What does that mean? It exceeds twice the units digit by 1. What? Is 1 more than twice the units digit, right? So how would we show that the tens digit is 1 more than twice the units digit? There we go. T equals 2u plus 1. The tens digit is going to be 1 more than twice the units digit. It exceeds twice the units digit by 1. That's what it equals. For our second equation, it goes into that reverse digit thing again, right? And it said if the digits are reversed, then the sum of the new number. Well, what is a normal two-digit number, first of all? How do we represent a normal, any ordinary two-digit number? It's just 10t plus u. But remember, we had a problem the other day where the digits got reversed. How do we represent a two-digit number with the digits reversed? 10u plus t. So it says if the digits are reversed, 10u plus t, then the sum of that and the original number is going to be 143. How would we finish out this equation? It says the sum of the new number, that's the number with the digits reversed, and the original number. How do we represent the original number? 10t plus u. So there's the original two-digit number, whatever it is. That's the new number because the digits have been reversed. That's the sum of the new number and the original number. And so the sum should equal 143. And that's the system of equations we were looking for. So it looks like we did not get the correct system. Let me check Gavin's work and see how he did. First equation, Gavin, is correct. And second equation is correct. All right, Noah, and actually we'll just kind of spread it around now as we see how Gavin did. What should Gavin have done next, Maddie? Absolutely. What do we get when we combine terms here, Maddie? And Brecken, as we look at this, everything inside me is like, I would love to do what? Maybe you don't think like a lazy mathematician. I see big scary numbers. I'm like, it sure would be nice if I could. Anyone? Knock an 11 out of everything. The only question is, does 11 knock out of that, right? But I mean, when I see an 11 here and an 11 there, it's like, it feels so good just to take an 11 out of everything. But can you divide this by 11? Let's find out. Check it out. Can you? Yes, Brecken, what do you get? 13. So sure enough, we can knock an 11 out of everything and make this u plus t equals 13. So I've taken this equation, boiled it down to this, and then down to this. So this is the same equation. I've just kind of simplified it down. Let me then also pull the first equation, t equals 2u plus 1, and let's make a system out of that. Let's see, Gavin, did you think to knock out the 11? You did not, and that's okay, you didn't have to. Oh, I'm kind of looking at your work here, Gavin. You're going to kick yourself. All right, all right, so then what should we do here? Let's stay with Brecken. Yeah, plug the 2u plus 1 in for the t, and that makes this equation become what?
U plus 2 plus 1
And when we combine the like terms, of course, we get class 3u. Let's also move the 1 over as a, to get 12. And divide both sides by 3. And Gavin, we do not get u equals 3. Class, we get u equals 4. Now, Gavin, you didn't knock out the 11, but as I look at your work, you got to 33u equals 132. And when you divide by 33, that's not 3. That'd be 99 divided by 33. You should have gotten the 4. So all your work was perfect. You just divided wrong and got u equals 3 instead of u equals 4. And obviously then, if you get a 3 right here, that gives you t equals 7, hence your number 73. But class, we should have plugged a 4 in there. And we should have gotten t equals 9. So we should have gotten what number then, class? 94. There we go. If the tens digit is 9, units digit is 4, 94 should have been our number. Now, Gavin, you could have checked this, though. What we would do is we would say the sum of this number and the number with the digits reversed, class, 49, should equal 143. Gavin, in your case, you would have said 73 plus 37 equals 143, and no, it doesn't. And that's how you could have caught your error. Where here, oh yeah, it does add up to 143. So right system, mostly right work, right up to the very end, just one critical division error, Gavin. But otherwise a great job. And then Noah, questions on setting up that second equation. All right, look across the page if you would, page 175, and word problem number 36. Read that for us if you would, Maddie, nice and loud. All right, so once again, another investment problem, Maddie. We've seen a bunch of these at this point, though this one takes on a little bit more more personality, I guess you could say. But we're going to still use the same basic headings here, Maddie. Good. P times R equals I. Again, that assumes time is 1 year, and yeah, it says annual. Okay, so we're good to go. Just wanted to double check. And there's the two different investments, and it doesn't specify what they are. It's just the different rates. We've got the 8% investment and the 12% investment. And how do you suppose we should plug in things for these different columns, Maddie? Yeah, X and Y. And usually, class, at this point, we got to get in a rut, and we say, well, add up the principal here plus the principal here, and equals the total principal. Add up the interest earned here and the interest earned here, and equals the total interest earned. But it's not given me totals. What does it say about the principal, about the amount invested, Maddie? Yeah, the second amount is $25,000 more than the first. They don't add up to $25,000. The second is $25,000 more. How would I write that in equation form? Yeah. So do we see, be careful, don't fall into a rut of assuming because it's an interest problem, it's going to be x plus y equals something, and 0.08 x plus 0.12 y equals something. That's not my first equation, but rather, as Maddie said, y equals x plus 25,000. Do we understand that? Do we see that? All right, so look at the second piece of information. Noah, let's come to you. What does it tell me about the interest? Yeah, the interest on the second amount exceeds the interest on the first amount by 5,000. Of course, it makes sense, right? If you're investing more money here, which we obviously are, quite a bit more, by the way, and it's got a better interest rate, of course you're going to make more interest on the second. It specifically tells me that this interest is $5,000 more than that interest. So, Noah, how might we set up our second equation? Gavin, help, or Brecken, help him. I haven't done that in a long time. I did that a bunch at the beginning of the year. You got to go back to like the first 20 lessons. Sorry about that, Brecken.
1.25 equals 0.08x plus 5,000.
There we go. $5,000 more interest than this earned here. This interest was $5,000 more than that interest. Does that make sense? And so, yeah, kind of weird. But as far as what we do to solve, not that much changes necessarily. What would I need to do? Let's go back to Noah. Well, how many places am I going to move the decimal? 2 places. So, 500,000. You're working this along with me, of course. All right, and then what, Maddie? Okay, we could do that. Or do you notice, class, I've got like terms lined up here, right? I could still use the addition method. Now, it's not xy equals number, but let's do it that way. We've done a lot of substitutions. I want to go ahead and give us some practice with a not normal, but still lined up, y equals x number, right? But I want to take a look at that here. So, Maddie, why don't we pick a variable to get rid of here? Yeah, I like the x better here. And so we need to multiply everything in the top by 8. So that gives us 8x, or 8y equals 8x plus, what's 8 quarters, class? $2. 200,000. We multiply by the 8. All right, and then what? Noah, back to you. Change the signs across the top to get negative, negative, and negative, which of course is going to allow the x's to drop out, leaving me with what, Noah?
4y equals 300,000.
All right, and then of course, class, we're going to have to divide away the 4. And what do we get when we divide 300,000 by 4? 75,000. All right, so apparently, class, this means that this guy invested $75,000 at 12%. But remember, y was equal to x plus 25,000. So 75,000 equals what plus 25,000? Anyone? Subtract away the 25,000. 50,000. There we go. So $50,000 invested at 8%. Did it ask for both rates? Yes. So there are our answers. So apparently, how much did he invest total, class? $125,000. Must be nice to have that kind of money. If you ever happen to have that kind of money, remember your math teacher. I do accept generous cash gifts, even from YouTube viewers. All right, page 288. Mail it to Grace Christian School. You can find the website on my YouTube channel, and they will redirect the money into the general fund. Anyway, I'm just kidding. I'm sure they would send it on to me. All right, turn to page 288 now. Questions on this word problem real quick before we move on? All right, page 288 then, and we've been working on multiplying radicals, and Maddie, we said in order to multiply radicals, what must be the same? The index. Now, would that make the radicals similar if the indices are the same? Noah? No. To be similar, what two things have to be the same? Radicand and index. But as long as they have the same index, we can multiply them. And we worked on that yesterday. I also showed at the end of the hour, you might recall, how to multiply radicals if the indices were different. Remember, we kind of did the opposite of that third reducing method. Instead of making the index smaller, it was like we started with the cube root of 11 to the first, doubled the things to get the 6 root of 121, like blowing it up bigger. That's algebra 2. Let's come back to algebra 1, though. Look at page 288, number 27. And we see a multiplication involving a radical. What do you suppose we would have to do in a problem like number 27? Bracken? Distribute, of course. And so we'll distribute, meaning we multiply the 3 by both things. And when you multiply 3 times 5, class, 15, super easy. Be careful here. When you multiply 3 times the square root of 3, what do you suppose we get, class? Bingo, 3 times the square root of 3. Not the square root of 9, right? Because this is a rational 3, which when you multiply by a rational 5 gives you a rational 15. When you multiply rational 3 by irrational square root of 3, the two don't mix. You just leave it like that. Does that make sense? Were we thinking the same thing Noah said, just not brave enough to say it out loud? All right, way to be brave, Noah. All right, how about this? The square root of 3, the next one, times the square root of 5 plus 2. What do you suppose we get when we distribute here, Maddie? I'm sorry, louder. Good, this time the two irrationals combine together, and it's the rational that just kind of mush it together with the irrational at the end. Make sense? So distribution, not a problem. Let's do another distribution here, the square root of 5x times x minus the square root of 2. Brecken, what do you suppose we get when we distribute the square root of 5x? Just ignore the existence of the x and just multiply. Square root of 10x. Yeah. Make sense? Not hard, just doing what you know to do, but because they're both irrational, they combine together into one new value. Because these are not both irrational, just kind of have to leave it. Write this one down on your paper. If we had the square root of 3 times the square root of 7 minus the square root of 6, what would we get for that answer, Maddie? There we go. Why couldn't I leave my answer like this? Oh, I cannot subtract. Remember, these are not similar radicals. Don't go subtracting to get square root of 3. Careful. But I'm not done because how would I factor 18? 9 times 2. Right, you can't combine these together, but you can factor one of them and reduce it down to get, Noah for redemption. Right, a negative 3 times the square root of 2. So we'll leave our answer this way. But oh yes, be very careful. Don't actually subtract because they're not similar. They're still not similar, but it's at least simplified now. Questions on that? All right, take a look at number 33. We have a 3 plus 5 times the square root of 2 quantity squared. Now, it's been a little while since we've squared binomials, but there are 3 steps to squaring a binomial. Bracken, do you remember what they are? Good. Great job. Square the first, square the last, multiply and double. Say that with me, class. Square the first, square the last, multiply and double. So when we square the first, Bracken, well, that's pretty easy. We just get 3. And then we've got to square the last. And remember what we've done the last couple of days. 9. Yes, 9. That's what I heard. I saw Maddie look over at Bracken. I'm like, did he say something wrong? Nope, I did something wrong. All right. 9. All right. Let's cut that part out. Just rewind the tape. Oh, no. Gavin deserves to see me screw up every now and then. All right, so you're good so far. I fixed it. I'm good so far now. Let's go to square the last. And we've worked on this the last couple of days. We said when we square a radical, we start by squaring the coefficient. That's the easy part. That's just 25. And then when we square a square root, class, we get the radicand. Thank you, Brecken. You were the only one who remembered it yesterday, too. Class, say this with me out loud so that sound cometh forth from thy vocal cords. When you square a square root, you get the radicand. Again, when you square a square root, you get the radicand. So, Brecken, when I square the square root of 2, I get 2, because that's the radicand. Notice I get two things. I get a 25 times a 2. And of course, because I'm squaring, what sign does all of this get, class? Whenever you square, you always get a positive. There we go. So we square the first, that's a 9, not a 3. We square the last, that's a 25 times 2, or in other words, class, we could just call this 50. And then we have to multiply and double. Square the first, square the last, then come back to the middle to multiply and double. We have to multiply this times 2, right? That means double. We don't always write the 2, we usually think that mentally, but I'll show it for this. So 3 times 5 squared of 2 times 2 would give me what, anyone? The square root of 2 is irrational. Is there any other irrational that it gets to multiply by? Nope. The 3, the 5, and the 2, those are all rational. The multiply and the double, that's all rational. That all gets multiplied. That does give me 30. But the square root of 2 is the only irrational thing. There's nothing else it can multiply by. We will get a 30 times the square root of 2. Does that make sense now? All right, but normally we'd be done. This would be my perfect square trinomial, right? Sort of. That's not a square because it's not got integers in it. It's got irrational values. But we can combine this and this together because those are both just regular rational numbers. What's my final answer going to be, Brecken?
59 plus 30 times the square root of 2.
All right, questions on this before we do a couple more. We're going to practice a few more of these, but questions. Do we understand the idea of square the first, square the last, multiply and double as it involves radicals? Let's look at the next one here. We've got an x minus 3 times the square root of 2x squared. And we're going to go to Maddie on this one. Maddie, when we square the first, that's easy, x squared. When we square the last, what do we get? Good, positive 9 times 2x. We square the 3. We square the square root of 2x to just get the radicand 2x, which means really, Maddie, this is all going to become an 18x. And then finally, we're going to multiply and double. I'm going to multiply these two things together, and I'm going to multiply a 2. What do I get when I multiply x, negative 3 squared root of 2x, and a 2? Perfect. Negative 6x times the square root of 2x. The only sign is this negative. 3 times x times another 2 is 6x. That's all the rational stuff. And then the only irrational, again, was that square root of 2x. It just kind of sticks around. And this time, nothing combines. So we're left with x squared. I would kind of move the positive 18x forward since there's no radical portion here. And then negative 6x times the square root of 2x. And there's our answer. We've done a couple of them now. Questions. Are we starting to kind of figure out how to work with radicals in our binomial squares? All right, let's take a look at number 4, or 37. And Noah, this one's just dirty, but I'm giving it to you anyway. Q plus 4 times the cube root of 4, all quantity squared. All right, Noah. The first part's easy, at least.
4q.
I'm sorry?
4q.
When you square the first, q squared. When we get to square the last, here's the deal, class. We know, say this with me, that when you square a square root, you get the radicand. Thoughts, Noah? Cube root. When you cube a cube root, you get the radicand, but when you square a cube root, you don't get the radicand. So what we're going to do here is we're literally going to square both parts. So what's that going to give me when I square the last?
16
Which is?
16.
There we go. We end up with a positive 16 times the cube root of 16. However, we can factor and reduce, Noah. Oh, it's a cube root. I don't care about 4. That's for square roots. 8 times 2, where we can take out a, and we end up with
32.
all right, so I'm going to go ahead and bring down my q squared here. All right, so that's square the first, square the last. Questions on squaring when it's not another square root. Just square the radicand then and move on with life. Technically, class, you could do that here, by the way. You could say square the first, 25, square the 25, and square the 2 to get 4, and then the square root of 4 is 2, but I'm lazy. I just want to go straight to the 2. You could say square the negative 3 to get positive 9, and square the square root of 2x to get the square root of 4x squared, which is 2x, but I'm too lazy. So I just say, hey, the square and the square root cancel, let's get the radicand and move on. Obviously that doesn't happen here because it's a cube root. Now we've got to multiply and double, Noah. That means multiply these two things and double, so there's another 2 we're multiplying. And they're multiplying a 2. Multiply and double. All right, so I'm going to go ahead and write the 2 right here. Rational, rational, rational. You multiplied all that. We're done with the rational. Now what's the irrational? Cube root of 4. And that's it. So I got a q squared, positive 8q times the cube root of 4, positive 32 times the cube root of 2. It's big, it's ugly, but there we go. Let me give you a couple more before we move on to the next problems in the textbook. Suppose we had the square root of 5 minus 2 times the square root of 3 quantity squared. Brecken, it's still a binomial squared. We still need to square the first, square the last, multiply, and double. Let's see what we get here when we square the first. Because we're squaring a square root, we get the radicand. When we square the last, sign, number, letter. Good, and now we gotta multiply and double. Remember, that means there's a 2 out here, if you will. Ooh, careful. What is rational here? I'm gonna go ahead and write the 2. I'm gonna write the 1. What are the rational things? Two times 1 times negative 2? Okay, what is 2 times 1 times negative 2? Right. Just multiply the rational. Now, unlike this time where there's only one thing that's irrational, one thing that's irrational, one thing that's irrational, here, Brecken, there are 2 things that are irrational, and they get to multiply also. Notice I don't multiply that by a 2 because the 2 out here is a rational 2. So when you multiply and double, that means there's a rational 2 that does not in any way affect the irrational. Do we see with 2 radicals how to square a binomial? Let me give you another one. Let's suppose we had a 3 times the square root of 7 plus, oh, well, we're not quite done. I could combine the 5 and 12, sorry. 17 minus 4 times the square root of 15. I didn't mean to stop too soon. Let's go back here. 3 times the square root of 7 plus 2 times the square root of 2. And let's square that binomial. And Noah, square the first, square the last, multiply and double. Okay. Let's square the first. Now let's come to square the last. Okay. And let's multiply and double. Remember, that means there's a 2 out here. times the square root of 14. There we go. Multiply and double. 2 times the 3 times the 2 is 12, and the square root of 7 square root of 2 combining is square root of 14. We're not quite done. That becomes class 63, and that becomes 8. I can combine the plain old rational 63 and 8 class, plus 12 times the square root of 14. Questions on, do we feel like we're starting to understand it now, after seeing several examples? Does anyone want to do one more, or we feel like we're ready? You want to do one more? That's fine. No, not a problem at all. I'm going to throw a variable into this next one. Let's suppose we have x times the square root of 3. Let's do a negative for a change. Negative 2 times the square root of 3x squared. That's going to really present issues later if I do it that way. Let me do a 10. All right. So bracket. Let's square the first. Okay, good. Now let's go to the end and square the last. Sign number letter, or sign number radical.
4 times 3.
All right. And then let's multiply and double. This is the fun part. Remember, there's a 2 out here. That's the double.
4 times 30 the square root of 30.
There we go. Negative 4x times the square root of 30x. Let's go ahead and simplify here to get, of course, let's simplify here. Positive 12x, and because there's no radical, I'm going to put that second, and then I'm going to slide this to the end. Is there any way to reduce the square root of 30? No, 4, 9, 16, 25, none of them go in. So I'll just leave this as negative 4x times the square root of 30x. You feel better about it now? All right, the rest of you feel confident, you know what to do with these. All right, let's move on to the next thing that we see then. We left off on 37. Let's pick up on 39. And Maddie, what is that thing in 39? There are 2 binomials. They're exactly the same, except one has a plus, one has a minus. What do we call that? Someone help? It's going to be a difference of squares, but that thing is called a sum and difference, right? The one has a plus sum and one has a minus difference. So a sum and difference does give us a difference of squares, Maddie, when I do what 3 things? Square the first, square the last, put a minus sign between them. It's been a while, hasn't it? All right, so let's try that together, class. Square the first, square the last, put a minus sign between them. Again, square the first, square the last, put a minus sign between them. And class, that's what every time we try to multiply a, what's that thing called? Sum and difference. There we go. So, we got the square root of 7 minus the square root of 3 and the square root of 7 plus the square root of 3. Maddie, we've got to square the first, then we have to square the last, then we have to put a minus sign between them. So I come to the very first and I square it. What do I get? 7. Then I come to the end and I square the last and I get, and I put a, and I get, hey, that worked out kind of nice, didn't it? Nice rational value. 2 irrational binomials, but nice easy rational value at the end. Do we see what happened? Let's take a look at the next one. We got 4 minus the square root of 11. Being multiplied by 4 plus the square root of 11. Once again, class, this is called a sum and difference. To multiply a sum and difference, we do what 3 things, class? All right, Noah, let's square the first, square the last, and put a minus sign. What do we get? 16. That was easy. Agreed? Especially helpful when you know that when you square a square root, you just get the radicand, right? And that's one of the reasons I've been emphasizing. It sure makes these things easier than square root of 121 and all that nonsense. Questions on sum and difference? Do we feel like we've got it? Does anyone need to do another one? Anyone want to do one more? Now, you look at number 43, square root of 3 minus 4, square root of 3 plus 2. Is that a sum and difference, Brecken? No. Now, one is a plus and one is a minus, but they ain't exactly the same otherwise. So, we're not going to square the first, square the last, put a minus sign, because it's not a sum and difference. But you know what these are, class? Similar binomials. I have like terms or like radicals in the first spot, and I have like terms or like radicals in the second spot. How do we multiply similar binomials, class? FOIL. First, outer, inner, last. Class, how do we multiply similar binomials? FOIL. All this coming back to you now. All the stuff we did last semester, we can do with radicals as well. So we're going to multiply the first two terms together. And what do I get when I multiply the square root of 3 times the square root of 3, Brecken? Square root of 9, which happens to just be 3. Okay, then we're going to multiply the outers. Now don't overcomplicate this, Brecken. Square root of 3 times 2. Perfect, 2 times the square root of 3. Then I need to multiply the inners. Now that's a negative 4 times the square root of 3. Right, negative 4 times the square root of 3. One's rational, one's not. So you can't mush them, you just leave it. And then finally we multiply the last together, Brecken. Negative 4 times 2. Negative 8. Now I want you to notice, we're used to outer, inner combining, right? And Brecken, outer, inner does combine to give me, ooh, we're not multiplying anymore, we're just adding. The negative 2 square root of 3 plus a negative, or positive 2 square root of 3 plus a negative 4 square root of 3. Right, we're just adding like radicals together. And then the first and last also happen to combine this time. Negative 5. And there's my answer. Negative 5, negative 2 square root of 3. I'll put the rational term first and the radical or irrational term second. Do we see how to FOIL with radicals? Notice, I don't like to do the outer inner in my head. I like to show all 4 steps when we're dealing with radicals, just because it can tend to complicate things. Look at number 45. We've got a 5 minus the square root of 2 and a 5 plus the square root of 5. Maddie, let's go ahead and multiply these similar binomials. How? FOIL, first, outer, inner, last. And Maddie, let's go through it one at a time. Multiply the first. Multiply the outers. The outers. Positive 5 times the square root of 5. Then let's multiply our inners. There we go. That's the negative 5 square root of 2. And then we multiply our last together. Negative square root of 10. And notice once again the, well, ooh, wait a second. Does anything combine, class? No. Because you know what? These aren't actually similar radicals, or similar binomials, are they? Because are these similar radicals? Then these aren't similar binomials. Nothing combines. Now you can still FOIL. You just can't combine anything when you do. Questions on that? All right, take a look at the next one. We have a 3 minus the square root of 3x. And I think I did erroneously say, by the way, that those were similar. They are not similar. How about these? Noah, are these similar? Yes, these ones really are. So we are going to actually get to do some combining of stuff on this one, unlike the last problem where we were not able to do it. So similar binomials, how do we multiply? Made too many blanks. First, outer, inner, last, got carried away there. Noah, walk me through. negative square root of
9 squared.
all right, first, outer, inner, last, right? And thoughts, Noah? It's a 3x right there. Okay, let me make sure. And the 12, does it combine with anything? No, not even here, because although you can simplify this, Noah, to just be a plain old, take the square root of 9, take the square root of x squared, 3x, right? 12 and negative 3x don't combine, so we leave 12 negative 3x, negative 1 times the square root of 3x. Questions on this one? Do we see the FOIL process? All right. Again, technically FOIL is just double distribution, and it may help you rather to just think double distribution as opposed to FOIL, depending on how your brain ticks. And that's not a problem. You find what works for you. Brecken, let's take a look at this one now, and let's go ahead and FOIL. Well, can we FOIL truly? Are these similar radicals? No. You can multiply these still, because I mean you do have, like indexes, but it's not going to have that outer inner combining. It's going to be kind of like this one over here, where when you FOIL, you end up with pretty much all 4 spots still. So let's take a look here. Brecken. First, outer, inner, last. First. Outer. Inner. Last. But there is a little twist on this one, because that last there, the cube root of 8, two. Right? Cube root of 8 is just plain old rational 2, isn't it? You can't take the cube root of 2, you can't take the cube root of 4, but you can get the cube root of 8 to get 2, and this time, just by happenstance, I'm actually able to do some combining. And the 1 and the negative 2 gives me, and then we'll put our radicals, the negative cube root 2 and the positive cube root of 4. And there's our answer for this one. Questions on this one? Questions on working with these binomials? Let's do one more together, and then I'm going to have you work some on your own. We've got number 51, x squared, plus the cube root of x, being multiplied by 2x squared, plus the cube root of x. Are these similar binomials, Maddie? Yes. I have like terms, x squares, in the first spot, and I have like radicals, cube root of x's, in the last spot. So the FOIL itself should work out pretty nicely for us here. All right, Maddie, go. Good, 2x to the 4th when you multiply the first. Perfect, the cube root of x squared. And once again, we can combine the outer inner here, Maddie, to get there we go. We'll tack on the cube root of x squared at the end, because you can't do anything with that, but we'll leave our 2x to the 4th at the beginning, and we get our trinomial answer here. Questions on this? All right. I want you to try 6 of these. See how far you can get in the time we have left. 30, 34, 38, 42, 46, and 50. for sake of time, pencils down, even if you're not finished. Let's take a look at these answers, see how you did on the ones you got to, and then kind of follow along on the ones you didn't. Here's just a straight distribution. 3 squared of 4, negative square root of 6, of course that's 2, so I get 6. Negative square root of 6, are we good on the first one? Question. Look at the next one. Square the first 5, square the last positive 2, multiply and double. Well, that's a 1 times 1 times the 2. Well, 1 times 1 is 1, doubled is 2. Of course, there's a negative. And then you also multiply the two irrationals to get square root of 10. 7 minus 2 squared root of 10. How many had that on 34? Question. All right. Looking here, square, 9w squared. Square positive 4 cube root of 36. Multiply and double. 2 times 3 times 2, 12. Of course, there's the w in there as well, and the negative. And the cube root of 6, that's nothing to get multiplied by. So that's what we wind up with. 9w squared negative 12 times w times the cube root of 6 plus 4 times the cube root of 36. Good to go on that one. Forgot to multiply and double. All right, you got a 6 right here. All right. Square, square, minus sign. Done. One could argue, well, in that case, isn't that a difference of squares? Not with integer squares, but I mean, you could technically factor it kind. Anyway, how did we do on this one? For those who made it that far. Anyone make it to number 46? All right, good. So we FOIL first, 81. Outers, 9 squared root of 5. Inner, negative 18 squared root of 5. Last, negative 2 square root of 25. Of course, the square root of 25 is 5. Times negative 2 gives negative 10. That combines with 81 to give 71. These combine to give a negative 9 squared root of 5. And for the last one, if anyone made it that far, maybe Gavin, for the sake of the video here, 4 times 3 is 12. For the first, the outer is a negative 4 cube root of 6, the inner is a negative 6 cube root of 36, and the last is a positive 2 cube root of 216, which is 6 times the positive 2 gives 12, which combines with the other 12 to get 24, and then these have no friends, so you just keep them. Questions on this, because you're going to be working similar problems for homework this evening. All right, your homework for tonight is to do page 288. Page 288. Numbers 28 to 52, page 288, numbers 28 to 52, every other even. So basically you're doing the multiples of 4. If it's on the 4 times tables, including 52, which would be 4 times 13, you're going to do that one. So every other even on the 28 to 52. We did the alternate evens just now. And then also one word problem on page 292, word problem 4. Page 292, do word problem 4. Don't forget, we do have a test coming up in lesson 169. That's Wednesday for those in here. Test coming up Wednesday. I believe, Gavin, you'll take it on Thursday or something like that. I don't particularly remember how your days work there. I think you're ahead of us by a day, something like that. We will be taking a quiz Monday over multiplying radicals. So we'll go over the homework, we'll do a little bit more review. Then we're taking a quiz Monday. Tuesday's our big review day. Wednesday, the test there in lesson 169. All right, have a wonderful rest of your day and a wonderful weekend. You are dismissed.